A pleasant day, grade 5 students. Welcome to our computer class at New Vision International School.
Our lesson is under Chapter 7, From Algorithm to Coding. It is entitled The Loops and Algorithm. The objectives of our today's lesson are the following. Number 1. Identifying the use of a loop in programming. Number 2. Converting an algorithm into a code. Before we start our today's lesson, you should prepare the following materials. Your book in computer on pages 84 to 85, a pen, and the Scratch program. To start with, let us have a recap. In this recap, you are about to watch a video. The video is very important for you to understand our today's lesson, so please pay attention.
In this video, we're going to have a look at movement and how you can get things to move around in your program. So I'm just using the cat, but this will work with any sprite. And I'm just going to move the cat over to the left-hand side to give him more room to move about. I'm also going to make him a bit smaller, so we can use these buttons at the top. If the arrows point inwards, that shrinks the sprite, so let's shrink him down a bit. Give him more room to run about. So when you create motion, the motion tiles are in the blue section, but I'm going to pick one from the brown section just to start my program off. So I'm going to start my program when I click on the flag, and then I'm going to go back to the motion section. So various ways in which you can get things to move. So you can move a number of steps, and if you do that, then it moves in the sprite moves in the direction that it's facing. So at the moment, if I move 100, it'll move to the right because that's the way the cat's facing. If I turn the cat using the turn tile and move forward, he'll move up and to the right because that's the way he's facing. You can also get the cat to point in a particular direction. So if you want him to face rightwards again, you can use this tile here, point in direction. And you can choose a direction, so it's a bit like points of the compass where 0 is at the top and it goes round. You can go either way actually, so although it says -90 is left, 270 degrees is also left. So you can point right again, or you can point towards a particular thing. So at the moment the cat is the only sprite, but you can point towards other sprites as well if you want to. You can also use X and Y coordinates, so if you want to move the cat back to the middle, for example, you can use 0, 0, so X goes across and Y goes up and down, but 0 is in the middle, so negative values of X will take you to the left and negative values of Y will take you downwards. And also you can glide into position, or you can change the X and the Y coordinates individually. You can either set them to a value, or you can adjust them by a certain amount. So changing the X by 10 will add 10. So if you want to take 10 away, you just need to put -10 in the box. So changing X by 10 will just move him right a little bit. But it won't matter which way he's facing. So if you always want them to move in a particular direction, regardless of which way they're facing, then that's the way to go. But just now we'll have a look at moving and possibly turning. So if we want to move the cat all the way across the screen from left to right, first of all we need to work out how far that is. So clicking move 10 isn't very far at all, so we need to work out really how far it is all the way across. So you can do that by trial and error. One of the good things about using a computer is you can just quite quickly try things and see whether they work. So 400 seems about right, but you could arrive there a bit more slowly than that. I know from experience that maybe a little bit more than that, maybe 410. See what that does? Yeah, 410 is pretty much all the way. So what we could do in our program is, if we wanted the cat to move from left to right, is just move 410 steps. So if you run that, he moves from the left to right, but not in a particularly realistic or convincing way. It just kind of jumps from left to right. You can also use the glide. So if you use this tile, glide, then it'll move more slowly. Anything that uses X and Y coordinates, if you position it in the place where you want it to end up, it will put the numbers in there for you. So if I put the cat where I want it to end and then move that to there, then it'll put the numbers in for me. So now if I move the cat over to the left hand side and I run that program, what we'll see is the cat will glide into position. However, I don't like using glide because it's effectively one step, although it takes a while. It doesn't allow you to do anything else at the same time. So what I prefer to do is break the motion down into a series of steps. So for example, rather than moving 410 steps all in one go, what you can do is repeatedly move a smaller number of steps. So for example, well, just to make the maths easier, if I say repeat 41, move 10. So what I'm going to do is I'm going to use this repeat tile from the control section, and I'm going to move 10 steps. So 41 lots of 10 is 410. So that's the same distance. So if I run that now, you get a similar effect to using the glide, except you can do other things after each step. So for example, if I want to speed the cat up or slow the cat down, I can do other things. Or if I want to make the cat look like it's walking, I can do other things. Now I keep having to drag the cat back over to the left hand side. So a better thing to do would be to go to the motion section and actually position him at the start of my program. So I've got this go to XY tile, it's filled the numbers in for me. So if I stick that back in at the top of my program, I won't have to move him back to the start every time. So now if I run my program, it'll move from left to right, but if I run it again, it'll start back on the left hand side. So repeated small movements give the appearance of motion. You can adjust the speed by the size and the number of steps. So if I wanted him to go faster, I could do fewer larger steps. If I wanted a slower, smoother motion, I could do more smaller steps. What I can also do in the control section is wait. So if I want the cat to slow down, I can just wait a small amount of time after each step. It doesn't have to be a whole number, actually. I can just wait 0.2 seconds, for example, if I wanted to. And if I run that program now, he'll move over. The cat will move in a series of steps. And as I said, the benefit of doing it this way rather than gliding is that you can do things like this. So if you want the cat to look like he's walking, remember in the first video we looked at different costumes. So the cat has two costumes with the legs in different positions. So if we want to animate him and look like he's walking, what we can do is we can just swap between the costumes each time he takes a step. So there's a tile here that says next costume. So if we slot that in as well, when we run the program now, his legs will move as he's walking across.
At this moment, let us answer exercise number 1. In this exercise, we are going to use the commands move 100 steps and turn 90 in order to write the algorithm that enables us to draw a square. In this exercise, we have given the first two steps, move 100 steps and turn 90. Do you have any idea what will be the next steps? Let's see. The next step would be move 100 steps. It is followed by turn 90 and move 100 steps again, followed by turn 90, move 100 steps again, and finally turn 90. But there is one vital command still missing. What do you think is that? That is pen down. Remember that pen down allows us to draw a line. If you're not going to use pen down, you may also use pen up. Now, I would like you to focus on the move 100 steps. How many move 100 steps do you see? Let us count. 1, 2, 3, and 4. The move 100 steps represent the length of the side of the square. And remember, the square has 4 sides. So we have 4 move 100 steps. What about turn 90? We have 1, 2, 3, and 4. Turn 90 represents the angle of the square. And remember, the square has 4 interior angles. How many steps do we have in all? We have 9 steps or 9 commands in order to draw a square using move 100 steps and turn 90. Now I'm going to show you how to draw a square using the Scratch program. So from exercise number 1, we're going to use move 100 steps and turn 90 degrees. So from exercise number 1, we use them as 4 times. So we're going to duplicate. There you go. And another one. Okay, so we have 1, 2, 3, 4, 4 move 100 steps. 1, 2, 3, 4, 4 turn 90 to the right. And now, for us to draw the line for the square, we are going to use pen down. So, put it here. Okay, now when you click it, there you go. So we have now the square. So as I told you, if you don't want to use pen down, you may also use pen up. So let's try. Let us now click this, and there you go. You have now another square. In exercise number 1, we use 9 steps in order to draw a square, but this time we are going to use the command repeat times in order to write the algorithm that allows us to draw a square with the minimum number of steps. The first step would be pen down that allows us to draw the line. The next step would be repeat times. This includes move 100 steps and turn 90. But how many times are we going to repeat move 100 steps and turn 90? Based from exercise number 1, and since the square has 4 sides and 4 angles, we're going to repeat these commands 4 times. Now, how to use repeat times in order to draw square in Scratch program. So first we are going to use pen down, and then we will go to control. Under control we will see repeat times. Okay, and since square has 4 sides and 4 angles, we're going to repeat them how many? 4 times. Okay, and this includes the following commands. We have move 100 steps and turn 90. So let's try. Let us click here, and there you go. You have now your square. At this moment, let us have exercise number 2. In this exercise, we are going to find the series of blocks repeated in each of the following scripts below. Then you are going to rebuild them in Scratch using the repeat command. In the given number 1, how many of the same commands do you see? How many play note 60 for 0.5 bits do you see? We have 1, 2, 3, and 4. How many play note 62 for 0.5 bits do you see? We have 1 and 2. What about play note 64 for 0.5 bits? We have 1 and 2. Meaning to say that play note 60 for 0.5 bits would be repeated 4 times. The play note 64 for 0.5 bits and 62 for 0.5 bits will be repeated twice. Now let's have the second given. For the second given, how many play note 64 for 0.5 bits do you see? We have 1 and 2. How many 65 for 0.5 bits do you see? We have 1 and 2. And also, play note 67 for 1 bit is also repeated twice. Meaning to say, in given number 2, the 3 of them are repeated twice. At this point, you are going to rebuild them using the Scratch program. From exercise number 2, I'm now going to show you how to rebuild the scripts using the Scratch program. So first, we will open the sound. Under that, you will see the play note 60 for 0.5 bits. So we're going to use the given from number 1. And how many times are we going to repeat this script? We're going to repeat this 4 times. Okay. Next, we have play note 62 for 0.5 bits. So we will go to sound once again. We're just going to change the play note into 62. And then we will go to control. So how many times are we going to repeat this? We will repeat this twice. Lastly, we have play note 64. So go back to sound and just change this into 64. And then go to control. Repeat it. How many times? Twice. So this is the given for number 1. I would like you to try to rebuild number 2 using the Scratch program. Do you still remember the first objective of our today's lesson? The first objective is to identify the use of a loop in programming. So what is a loop? The loop helps us to repeat a set of instructions several times, meaning to say, it helps us to minimize the number of steps. Here is a diagram that explains the functioning of the loop. Always remember that the computer reads the instructions from top to bottom, and the blocks inside the block loop will be repeated forever. Look at the algorithms below. Build the appropriate scripts in Scratch program. Then, draw the result obtained. Always remember a block corresponds to each line. Let's have number 1. When the letter C is pressed, in the Scratch program, it is in the form of when C key pressed. Number 2. Set the thickness of the pen to 5. In the Scratch program, it is in the form of change pen size by 5. Number 3, repeat 10 times the blocks. In the Scratch program, it is in the form of repeat 10 times. Make 100 steps forward is in the form of move 100 steps. Make 100 steps backward is in the form of move negative 100 steps. And turn 36 degrees to the right is in the form of 36 degrees with this symbol means to the right. Always remember, in motion movement, positive numbers means forward. Negative numbers means backward. Now I'm going to show you how to build the scripts in Scratch program for exercise number 1. First, we have when letter C key pressed. So we will go to events, wherein we can find when space key pressed. We will just change it into C. Then set the thickness of the pen to 5. So we will go to pen. That is in the form of change pen size by. So we're just going to change it into 5. And then repeat 10 times the blocks. So we will go to control. We will see repeat 10 times. And what should be repeated? We will go to motion. We have move 100 steps forward. So change it into 100. And then move 100 steps backward. So that would be changed to negative 100. And then turn into 36 degrees to the right. So this is now the scripts build in the Scratch program. So let's try what will be the result. When you click it, as you can see, it is just moving. There is no line. So what do you think is the missing script? We can use pen down. So we're just going to drag it, put it here. Okay, let's see. We're just going to press letter C in order to see the result. And there you go. We have now this result. Let us now have exercise number 2. Number 1. When the letter E is pressed, what do you think is the code of this in the Scratch program? That is when E key pressed. Number 2. Put the pen in writing position. This could be pen down or pen up. Number 3. Repeat the blocks 10 times. That would be repeat 10 times. Move 20 steps forward would be move 20 steps. Turn 90 degrees to the left would be turn 90 degrees with this symbol means to the left. Make 20 steps forward, that would be move 20 steps. And turn 90 to the right would be turn 90 degrees with this symbol means to the right. For exercise number 2, I will show you now how to build the scripts in Scratch program. First, we have when the letter E is pressed. So we will go to events. That's right. So we will drag when space key pressed and we will change it into E. Then followed by put the pen in writing position. So we will go to pen and we will choose pen down. And then we will repeat the blocks 10 times. So go to control and choose repeat 10 times. This includes the following motions. First, we have take 20 steps forward, so that will be move 20 steps, so change it into 20. Then turn 90 degrees to the left, so this is to the left, change it into 90. Then another move 20 steps forward, so we have move 20 steps, and then turn 90 degrees to the right. Okay, so let's see what will happen. All you have to do is to click or press letter E. So just press it, and there you go. You will see the output. Okay. And for the remark of the day, do not forget to build the eraser block in order to do the following. First, to delete all the drawings, and secondly, to take the sprite back to its initial position. And always remember, we can find the eraser block under the pen script in the form of clear block. Thank you for listening, students. I hope you learned something from this video. Have a nice day